elevator music.
Okay, so we'll get going then. Adam, sorry, I cut you off there. Was it anything?
No, I was just gonna say we need some elevator music before we're waiting for the recording.
Yeah. Okay. Well, we'll get going now. Welcome to the SingularityCE community call for October. So on the agenda today, first thing we're going to sort of continue the vein we've had in some previous sessions, because we've had quite a bit of interest in this topic, which is sort of this SBOM, the software bill of materials support and scanning and attestations and things, and being able to use tools to do those tasks on SIF container images. So I'll hand over to Adam in a minute to talk about where things are going on that. After the demo and the chat about this SIF to test support, we'll go over the security release of SingularityCE 3.10.3 today. I'll give a bit of a development update towards 3.11, and then we can open the floor for anything else. So Adam, do you want to take the screen and show us what you have?
Yeah, sounds good. Oh, it says host disabled participant screen sharing. Are you able to re-enable that?
Apologies.
All right, cool. Can everyone see a VS Code window?
Yeah.
Okay, great. Yeah, so I guess maybe it makes sense just to start with a quick refresher. It's been a while since we presented this the first time. I guess, the first question we get in this is really, what is a software bill of materials and what does it allow you to do? It's exactly what it sounds like. The state of things today, containerization has taken off, and it can be challenging if you're running a system just to figure out what all the packages are that are in your software, especially when you've got an increasing number of container images and you've got an increasing number of people building them. It can be a challenge to just kind of stay on top of what's in there. And why that matters, when a vulnerability report comes out for a component, actually the first problem you have is just, do I have that component running anywhere? And so in the cloud native space, there's a team called Anchor out there who's been working on this. They're able to take a Docker, an OCI image, and scan it with their tool called SIFT, and that'll drop out a list of what's inside of it. And then they've got a second tool called Gripe, and this allows you to take that SBOM and do something with it. So before I kind of get into demoing, that's kind of the high level. And then where Singularity comes into this is, we started months ago now publishing SBOMs with some of our open source projects. So SIF itself has an SBOM that gets published with each release. I believe Mike's SES build client that he publishes also ships an SBOM. And when we started doing that, we had people coming to us and saying, hey, wait a minute, why can't I do this, with a Singularity image? If you guys are publishing these, Docker containers and binaries with SBOMs, it would be nice to be able to do that with Singularity images as well. So from there, we reached out to the Anchor team on the open source side and just said, hey, would you be interested in adding support for SIF within SIFT? It's a little confusing, as well as Gripe. And the last time we presented, that's kind of where we were at. That work had just been completed. And that allows you to take a SIF image and scan it, really get an SBOM out of it, and then scan that. So let me just pull an image before I get too far here. So there's obviously some ways built into Singularity. I'm using SIF tool here to see what's in it, but This is really quite opaque. Of course, I can run the image and have a look around, but if you're trying to do this with automation or at scale, it doesn't scale very well. So SIFT allows you to just take packages, parse that image, and you'll see that I've actually passed in a SIFT image here. So the last time we presented on this, this was kind of where that work was at. This is great, and if you're doing this in automation and we do this, you might output this somewhere. So there's a bunch of different formats that it supports, but I'll select JSON for now. And then just cut that. You'll see in here, there's all kinds of details about what's in the image. It's an absolutely massive amount of detail. There's every single file, the packages it finds. It supports a bunch of different ecosystems. Once I have that file, that's where Greg comes in. So now I can do SBOM. And that's actually taking, everything that's in that software bill of materials now and scanning it against their vulnerability database. So they pull from a bunch of different places, CVEs. I think they're actually pulling from GitHub Security Actions now. And at the end of the day, this is a quickly evolving tool, but it allows you to get visibility into it with the SBOM, and then you can take that SBOM and scan it. If you kind of ignore the technical details for a moment and look at this in what might happen if, say, somebody else has given you software and an SBOM, the SBOM itself, there's really nothing saying where it came from. It's very easy to edit. So if you're removed from, where you've got the software and you've got an SBOM with it, you really have no way to validate that it hasn't been, modified to hide a vulnerability or corrupted in transit or any of that. And that's really where attestations come in. So an attestation in the context of an SBOM is I'm taking that bill of materials, and me as a user or as an organization, I'm attesting to it. So, rather than just a file, it is now a file that can be cryptographically verified that it came from someone. Somebody made that statement about it. So, for example, Sylabs might attest to an SBOM for Singularity at some point. And that would be us making a statement that, hey, when we scanned it with SIFT, this version, this was the result. And maybe even, this was the result on this day, and a bunch of other details about it. So SIFT has had a test support for a few months now. They are reusing some code from the SigStore project. And SigStore is really, quite much larger than what's happening here. But it's really all to do with supply chain security. And the part of that they pulled in was the attestation support. So to use that, it's quite easy. We just do, let's see here, testing my memory a bit here. Oh, actually, before I do that, I need to generate a key pair. So so I'm just going to create a dummy key here. So you'll see, this is just dumped out a public key, and this cosign key is a private key. Cosign has all sorts of things you can do with these keys. They have different keying mechanisms. If you want to use, certificates, if you want to use, there's some very forward-leaning ways of doing signing that actually don't involve certificates with long lifespans. This is kind of the simplest method, so I'm just going to do that here for ease of demo. So now that I've got a key pair, like any public-private key, if you're used to doing this with Singularity, cosign.key is the one you have to protect. Cosign.pub is the one you give to other people to verify whatever it is you're signing. So what I'm going to do now is, rather than doing SIFT packages, I'm going to do SIFT attest, and I'm going to output that in JSON. Going to give it that key I just made, private key. And then I'm going to output the attestation to a file. And finally, I'll give it the image. So you'll see here that this looks very similar at the CLI level to what we got with SIFT packages. If I take a look at that file, though, it is still kind of looks like JSON, but there's a bunch of stuff in here. And this is really the attestation. So you can see here, this is an in toto attestation. That's actually the format that the attestation's in. This payload here is actually the SBOM itself. And I suppose I could actually paste that in, maybe. That took a while. I believe that's in base 64. And you'll see here, this is kind of exactly what we had in the SBOM originally. The difference is at the end of that file, there's a signature. So this is, what was created when I gave it that key and I used the attest command. So now what I have is the SBOM. I have a signature with it in the same file. And now if I flip over to Gripe, I can do the same thing we did before. I can scan that SBOM that's in the attestation. But we're taking it a step further now. In addition to scanning the SBOM, we're actually verifying the integrity of the bill of materials against the key. So to do that, I'm going to do Gripe. And then rather than the SBOM, I give it ATT for attestation. And finally, I'm going to give it the public key. And you'll see here, very similar output, except for this middle step here. And that's actually doing a cryptographic validation that this attestation, the signature within the attestation, actually lines up with the SBOM. So what this means is if, let's say you had a nefarious actor, maybe even an insider somewhere who, has found a vulnerability in a known piece of software, that just came out today. They know people are doing scanning, maybe on a nightly basis or something of everything running in production. And they want to hide that. Well, with the original one we did, if they can modify that JSON document, then they're kind of in business. They've managed to hide the fact that maybe a piece of software is using a particular version of a component. Here, though, if you were to go in and try and modify this encoded SBOM, the signature wouldn't match, and you'd actually get a failure at this stage, and you wouldn't be able to scan the image. This is quite down in the weeds here. The reason this matters, really, zooming out kind of engineering speak and the tools themselves. Today, the supply chain behind software is really the thing that attackers are going after. It's kind of the soft spot, it's the weak point in our practices as people who make containers and ship them and do things with them. These tools really allow a software team who's creating software to start documenting some of that, to put some trust behind it. And then consumers of software, be that an individual or even a business, can actually start to automatically verify certain things about that. They can verify the authenticity of an SBOM. They can scan it with Gripe and get vulnerabilities out. There's loads of things that there's a whole ecosystem beyond this of just SBOMs and scanning those against CVEs. But that's a huge, kind of growing field, and we're kind of step one of many going down that. But so that's where we're at today. I will mention that I'm actually running this off the main branch of Anchor Sift. So this is not released yet. I think it was merged a couple of days ago. Expect a release in the next week or two that will have that in both Sift and Gripe. After that, really, we're getting a lot of great feedback from the community about the ways they're using this, the ways they want to use this, even some things that have been broken in the implementation. So really appreciate everybody who's speaking up and giving us feedback on that stuff. We love to kind of have that discussion. We've got some ideas about where software supply chain security is going in high performance computing. But it's, really the stronger that gets, it gets a lot stronger the more voices we have speaking up and saying, hey, I'd rather do it in this way, or what about this? So yeah, lots of places to do that. The Anchor folks in their Sift and Gripe repos would, are very open to getting issues there. And of course, they've got a great community Slack, as do we. So depending on the feedback, yeah, find the right venue there, and hopefully we'll keep moving this forward. So that's about all I have to demo today. I know I've spoken for a while. Hopefully it's clear, but I'll open it up in case anyone has any questions about it.
So it looks like Dave just dropped a question in the chat, Adam. I don't know if you see that.
Oh, all right. Let me have a look here. Okay, so just for the benefit of everyone on YouTube watching this later, won't there be a huge number of false alarms on vulnerability scans? The vast majority of them might not be applicable, right? These are not Docker containers where system services are common. That can be the case, yeah, for sure. I do think that's part of the discussion that's always been there around scanning, is it's only as useful as the output is accurate. I will say that what's happening in the world today at large is there's a huge focus on solving that problem. So even if you just look at the Golang ecosystem that we're in, because we're working on Singularity, at the language level, they're actually starting to address that. So rather than just having this component has a CVE, you're using it, they're actually starting to dive down into building a database that says this version, this specific function or method actually has an issue. Since this version to this version in this package of this module. So yeah, I mean, I do think that's a concern today for sure. You cannot take this output if it says there's a vulnerability and just assume that you are insecure. It takes more investigation than that. But I guess the flip side of that is that if you do have a report like that and you have the tools to generate it, you kind of have to ask yourself too of, okay, if I've gone to that effort, why? So for private industry, that's a pretty easy justification these days. A lot of folks in a lot of different vertical markets have seen their competition affected by big attacks. And then also the other way that this can be used is high profile vulnerability comes out. So log4j is a great example of this. And you just on day one, you want to ask your teams, hey, do we have that anywhere? Or where is it in our infrastructure if it's running today? And you might want to do that on an HPC system as well, right? As an administrator, you might want to say, are any of the things being run vulnerable to this critical vulnerability that just came out yesterday? SBONs can be used in that way as well. So it's not, preventative, but it can be a quicker way rather than, manually intervening to look for a vulnerability. If you've done the legwork ahead of time to generate an SBOM or obtain an SBOM for every piece of software you're using, answering that question becomes quite easy. Now I can just search through a machine readable set of documents, looking for a specific version or a range of versions of that software. So yeah, I think that the answer to your question is yes, there will be false alarms. There still has to be a human in the loop here. And every organization or individual who's using this needs to look at the cost of doing that versus the value they get. I think that the tendency, certainly in private industry these days, is towards a more cautious approach and actually investing some time and resources to solve this problem. But yeah, I mean, you cannot say that you've set this up and now we're good, now we're secure, as with anything in security. So yeah, Dave, did that answer your question?
Yes, thanks.
Awesome. Any other question before I turn it back over to DT? All right.
Okay, thanks, Adam. So from talking about SBOMs and security scanning, we'll jump into talking about the release today. So today we put out a SingularityCE release 3.10.3, and this one is a security release. So just to tell you a bit about what's in it, go over to the release page. What you'll find and what's been published on the mailing list and in Slack and so on is this information here. So the release is relatively small one. It's really just addressing the security issue that's described here. And then there's a bug fix brought in, which fixes an issue where a history of bootstrapping a container wasn't present. But we'll concentrate on the security issue here. Singularity brings in SIF, the Go module, the library in essence, which implements the Singularity image format of low-level functionality as a dependency. And there was a vulnerability found in this relating to verification of signed images. So when you sign an image, there's a hash algorithm involved in a couple of places. And what was happening was that in a particular place, Singularity, when verifying a signed image, it wasn't checking that that hash algorithm was in a list of secure hash algorithms. So in theory, what could happen is, although Singularity itself always signs an image with a secure hash algorithm, someone malicious could, by means outside of Singularity, generate a SIF image and sign it with a hash that is known to be insecure. So you might have heard about the SHA-1 insecurity and collisions, which came up particularly related to Git, how Git takes hashes of commits. And what can happen here is that the algorithm is vulnerable to attacks where you try and force a collision of hashes, so that you can kind of cover up some malicious content by making it appear with the same hash as real content. Now, if we go through to the CV link, which comes across to the GitHub security advisory, what you'll see is that it comes out with an explanation and the impact here. And you'll see the severity level is low. Now, this is really related to how this is, something that's hard to exploit. It requires expertise, and there are only kind of specific downstream exploits that it potentially enables. But we still encourage all users to upgrade. As a kind of workaround here, you may choose to independently validate a hash algorithm for a signed image. But the best thing to do is update to the latest version of Singularity, which pulls in SIF 2.8.1 and addresses this issue, because now when it's doing a verification, it's going to correctly check that the hash algorithm that it sees in the verification when it's looking at this image is in the list of known, safe, strong hash algorithms. Ad, is that a fair explanation? Anything you want to add?
No, yeah, I think that's great. Dad.
Okay, just to jump back then, the bug fix, I briefly mentioned this, but maybe I should explain a bit more. When you build images in Singularity, you can build an image which is based on an image that you previously built, which might even be based on an image that you built before that. And in Singularity 2, there was a bootstrap history directory hidden in the image, and it kind of kept the history of the definition files through time, which were used to build all the ancestors of your image. And in the 3 release, that went away. It wasn't included, and this was really a regression, and it's not been there for a long time now. We've been on Singularity 3 for some time. But we've now fixed this kind of missing information so that if you build images based on prior Singularity images, the kind of information about the ancestors will be present. Okay, any questions about that release today? All right, jump on then and give a quick update of where development work is going at the moment. So if I go over to the pull requests over here, we can kind of scroll through and we can see what's coming into SingularityCE at the moment. I'm going to pick up this one first and just talk about this a little, because it's something that people might hit or might start to hit in the future. What this is about is that if you're trying to build a container by bootstrapping a Red Hat kind of derived distribution, then you're using the RPM tool. You're doing a bootstrap to kind of extract the base packages into a directory, and that uses the RPM tool on the host system, or YUM or DNF on the host system, to kind of bootstrap the container before you enter it to do any thing in the post section of the build. And here we're not talking about if you pull a Red Hat or a CentOS or an Alma or a Rocky image from Docker. We're talking about it if you're trying to bootstrap it from the mirrors themselves, using the YUM bootstrap agent in Singularity. Right, so what's happened now is that Fedora, where the upstream work on RPM and YUM DNF takes place, has changed where it puts the database path of RPM. So RPM has to keep a database which lists all the packages that are installed on the system and so on. And previously it was in varlib RPM. And now with Fedora 36, it's moved to a userlib sysimage RPM location. And the reason for this change is kind of documented in this Fedora change document here. There's a bunch of information about the impact and so on. And it also points out that this is something which is being picked up in OpenSUSE and is already in the immutable Fedora Silver Blue distribution. But underlying this change is that distributions want to try and move user-related things under user as they sort of think about more immutable base operating systems and kind of separating things out differently than the traditional hierarchy that you've had. The problem with this is that Singularity has a check in it which looks to try and confirm that the RPM database path on the host is set to this value, the old value. And the reason it does this is because if you try and use RPM to bootstrap a distribution, but you're on a Ubuntu or Debian host, it's set to something weird and it just won't work. But now we need to allow this new location, which Fedora 36 and other distributions are going to start to use. If you're going to bootstrap Fedora 36, you can now do so successfully from the main branch of Singularity. And then it'll also, if you're using Fedora 36, it'll spit out a warning saying that if you are trying to bootstrap something older, then you might need to set up an RPM macros file to tell the bootstrap to use the old location, because we need to create, say, a CentOS 7 container with things in the old location inside the container file system, because all of the CentOS packages are kind of set up to deal with this location rather than the new location on the host. So that's a bit of a long-winded explanation for something which is perhaps not used that often, but I wanted to bring it up as this is an issue and a workaround that more people will need over the coming years as we move forward with RPM distributions and they sort of catch up to what's been now changed in Fedora. Any questions about that one? Okay. Other than that, the main thrust of the work in SingularityCE at the moment is some refactoring. So what you'll see if you've been looking at the Devil channel or so on are some quite large PRs with names like this one. And if we go and look at this PR, what you'll see is kind of a huge number of lines being changed here. The prior one to this was even more complex. And what we're actually doing here is we're working towards something which is in our roadmap for 3.11. So in 3.11, we've said we're going to have experimental support to run shell and exec native OCI containers, so containers which are in an OCI format on disk, through the runC low-level runtime, but you'll run them using the familiar Singularity CLI, and it's going to support a subset of the flags, the options that Singularity supports. So we're doing this as part of our roadmap towards 4 and the direction we're taking towards greater OCI compatibility. And the refactoring work is really so that we have a place to put this functionality in. Until now, the code that Singularity uses to start a container, much of that has been in the command line interface layer, which has never been a very good place for it, but it's all coupled very tightly to the command line interface. So we have to move it out so that we have some separation there, and then we can kind of make a place for this OCI runC engine code to go so that we can add this new functionality. So things might look a little bit kind of slow on the change log, but if you look at some of the PRs, you'll see some quite big changes going on now. And then in a couple of weeks' time, you'll see probably much faster pace of sort of more visible changes related to this functionality. So that's just a little update on where we are in development right now. We can open it up for any other business, any other questions at all that anyone has. We'll do our best to answer, or we can discuss anything, any topics that you would like. Okay, quiet today. Nothing at all, Dave? Right. Well, we will give you back the time to the top of the hour, and hope you have a nice rest of the day. We look forward to seeing you next month, where we'll do another demo. We'll try and move off the SBOM theme a bit into something different. Hopefully what we'll be showing is some of this OCI work that will appear relatively shortly after the call next month towards 3.11. So thanks for dropping by or listening in, and we hope to see you next month.
Thanks, everyone. Take care.